So the axis of symmetry is going to pass through 2 on the x-axis. Then, okay, for our vertex, the vertex is going to be located at 1, 2, positive 1. So our ordered pair for the vertex, okay, which is the vertex is located at that 2, 2, 1. All right, then for the y-intercept. Now the y-intercept on this one, the y-intercept is going to pass through -3 on the y-axis. So let's just review that real quick. Okay, with this, of course, f of x. Okay, that is equivalent to saying y. So down here we have f of x is equal to a positive leading coefficient. So anytime we have a positive leading coefficient, okay, remember we have the smiley face. Okay, but then with the negative, okay, the negative leading coefficient is Mr. Grumpy Gill, so he's going to be a big frown. So negative, okay, he's negative, so he's going to frown. All right. Okay, now let's take a look at this. Graphing parabolas using a table of values. Okay, the way we're going to do this, just like what you did back whenever you did linear functions, okay, also whenever you did exponential functions, we did this as well. Okay, we're going to choose a domain. Now, the domain that you're going to use has to be a specific, and I have to give that to you. Okay, I'm going to have to give you that specific domain. Now, for this particular one, the domain that we're going to use is 1, 0, -1, -2, and -3. Okay, that is the domain that we're going to use. So now we're going to find the range. Okay, once we have our domain, okay, we're going to find the range. Of course, each of those are ordered pairs. We're going to plot each of those ordered pairs to draw our parabola. Okay, now the way we're going to do this, okay, just like what we do with linear functions, just like what we do with exponential functions, okay, we're going to take the x, or the domain. So for the first one, we have 1, so we're going to replace the x with the 1. Okay, now in this case, we happen to have two x's within the expression, so we're going to replace each of those. Okay, with the first one, we're going to replace that with 1. So now, very simply, once you do that, those two x's with that number within the domain, now you're going to solve the expression. So for the first one, we just do our exponents first. 1 squared, okay, which you get 1. 3 times 1, okay, which is 3. 6 times 1 is 6. And minus 4. And you just solve that. 3 plus 6 is 9. 9 minus 4, of course, is 5. Okay, so our first ordered pair is going to be 1, 5. So when we go to graph our parabola, that's our order. The 0, once again, replacing x with 0. So on this one, the first two terms there, that's just going to end up being 0 because anytime we multiply anything times 0, it's 0. So all we're left with is -4. All right, then for the times -1 squared. And once again, this is important. If we have we have to do the exponents first. Okay, in this case, we have a negative. Negative times negative is positive. So that's going to end up being 3 times 1 for 3. 6 times -1 is -6. Okay, and minus 4. Okay, that's going to give us a -7. Now what I would like for y'all to do, go ahead and finish this one out. Get the last two numbers there, -2 and -3. All right, anybody make any observations about the last two numbers down there? Eric? Okay, we got -4 on this one, right? Okay, what's that last number down there, though? 5. All right, so let's take a look at our range. Okay, what do we notice about our range? The numbers within the range. I'm sorry, say again. Yeah, so what we notice is, okay, we kind of have some repeating numbers up there, right? Okay, we got the 5 and -4, but then down the bottom we got -4 and 5. Okay, and that's going to happen with parabolas. So anytime that you're finding the range of a parabola, okay, and you've got your vertex in there, because that middle ordered pair, that's going to be your vertex, that -1 and -7. That's your vertex there. So on either side of the vertex, your range mirror one another. Okay, so we got the -4s, but then we have the +5s. Kind of opposite sides of your axis of symmetry. Okay. All right, and that's what the parabola would look like. You know, that's about the ugliest. looking parabola there is. Yeah, and what y'all do, okay, with these, whenever you find your range, and you find those ordered pairs, you go ahead and graph that. Now, okay, going back to pairs here. Okay, this right there, okay, that's our vertex. Okay, vertex, which is located at -1, -7. Okay, just like what we discovered back here on our table. Okay, that's our -1, -7. That's in the middle. Okay, then, okay, we also have these two ordered pairs. Okay, right there. Okay, those two ordered pairs. So we got 0, -4, but then also -4. Okay, just like what we have back here. And then finally, we have those last two ordered pairs. Okay, last two ordered pairs. Okay, the 1, 5 and the -3, 5. Now, what's our y-intercept on this one? Okay, what would be the y-intercepts for this particular one, David? -4. And what would be the axis of symmetry? Okay, what is our axis of symmetry? Joe? -1. That's right. Okay, axis of symmetry, which would be right here. Okay, passes through -1. And of course, this is our y-intercept right here. Okay, that -4. Okay, I'm going to let y'all try this one. Okay, this time your domain is going to be -2, -1, 0, 1, and 2. Okay, once again, that's what your range is going to look like. Okay, then for your parabola, it's going to be located here. So what would be our axis of symmetry for this parabola? Okay, what's our axis of symmetry? Yeah, it's going to be 0. So it just passes through. And go right down the y-axis this time. So our axis of symmetry would be 0. Okay, what's the y-intercept? 3. Okay, it's going to be 3. As we already stated, okay, for our vertex, it's going to be located at 0, 3. Okay, so now the last concept we're going to look at today, identifying the three characteristics from functions, our axis of symmetry, our vertex, and the y-intercept. Now the way we're going to do this, okay, we will do this algebraically, okay, going through the process, finding these three components of a parabola. Now the first one you're always going to find is your axis of symmetry. Okay, that'll be the first one. Then for the second one, that will always be your vertex. And the last one, okay, which will be your y-intercept. Okay, now the way you can remember that, or at least the one that you're always going to start with, axis of symmetry begins with A. So, of course, in the Greek, alpha, you get your alpha and omega. Alpha is the first. So, axis of symmetry is the first. So, that's the one you're going to begin with. Okay, so, for this one, our axis of symmetry, the way we're going to find that, we're going to use this formula. X is equal to -b over 2a. Now, the reason that it's x is because that's going to be the x-intercept. Okay, that's going to be your x, or it is for your axis of symmetry. Now, with this, and the reason we have b and a is because when we look, of course, at our quadratic function, okay, within the quadratic function, we have the ax squared plus bx plus c. So in this case, our a is going to be the 2, and the b will be the 4. Okay, so very simply, we're going to replace the b with the 4, replace the 2, replace the a with the 2. Okay, simplify that, we get -4 over 4. So our x is equal to -1. Okay, now for the vertex. Now the vertex, what we're going to use, okay, we're going to use that function. Okay, y is equal to 2x squared plus 4x minus 3. Now, we just found and this is the axis of symmetry first, because we're finding the x. So we're going to use whatever that x is, in this case -1, and we're going to replace the x within the quadratic. Alright, so now we solve that expression. Start off with the exponent, -1 times -1, which is 1. That's going to just give us 2. And 4 times -1 for -4. Okay, then we have -3. And the y, okay, which will equal -5. Now remember with the vertex, we do have to write that as an ordered pair, okay, because it's at one point on the parabola. So it's -1, -5. There. Okay, now the last one we're going to look at, this is probably the most challenging one of all. Okay, the y-intercept. This really takes quite a bit of effort. Not really. Okay, with our axis of symmetry, it's always just going to be the c. So in this case, our c is -3. So the y, okay, which is -3. Yeah, it's tough, isn't it? So you guys go home tonight, make sure you practice on finding that y-intercept. It's probably going to take you a while. All right, let's do this. I'm going to have you all do the axis of symmetry on this one. Okay, once you find the axis of symmetry, go ahead and stop because there's something about the vertex before you move on with this particular one. So go ahead and do your axis of symmetry, find what that is, and then we'll do the vertex together. Okay, we're starting to run out of time here, so let's go through the axis of symmetry. Okay, axis of symmetry. Okay, once again, we're doing x. Oops. Okay, x is equal to -b over 2a. So for this one, okay, we got our b, which is 6. -6 over 2 times -1 is -2. Okay, in which we get +3. So x is equal to +3. Okay, now what I need to show you on the vertex for this one, since we do have a negative, 1 is our leading. Okay, the way that you need to view that, we got y is equal to -1 times x squared. So our x, of course, is 3. So we're going to replace the x with 3. So we get 3 squared. Okay, then we have plus 6 times x, or 6 times 3, and then plus 4. Now, the reason that's important is because if I were to group that negative in with the 3 squared, which is positive, well, it's actually going to end up being a negative. So you have to view that as that's a -1 times x squared. That's what we do with all of our coefficients anyway. Okay, so we're going to do the coefficients. So if I had like a 2x squared, you'd actually do the x squared first and then times your 2. Okay, so for this one, that's going to end up being -9 plus 18 plus 4. So for this one, okay, your ordered pair is 3, 13. And what's our y-intercept? Yep, 4. Okay, last number there, 4. That's your y-intercept. Okay, any questions from today's lesson? Ethan? Okay, it's a leading coefficient of -1. So at -1, okay, we replace the a with -1. -1 times 2 is -2. It's a good question. For this assignment, okay, it's going to be page 550, 22 through 26 even, and then also 28 through 42 even. Now, as far as 22 through 26 even, okay, let's do this. Copy that down, but then, okay, I'll need to give you the domain for those first 3 problems. Okay, I have to give you the domain for those first 3 problems. Okay, so for number 22, okay, 22, the domain is -4, -3, -2, -1, and 0. Okay, once again, -4, -3, -2, -1, and 0. All right, number 24. Okay, 24 is 4, 3, 2, 1, 0. Okay, once again, 4, 3, 2, 1, 0. 6. That is 3, 2, 1, 0, -1. Okay, once again, 3, 2, 1, 0, and -1.